Hello friends, myself from LJIET Institutes of Engineering and Technology. So in last lecture we discussed about what is coefficient of fluctuation of speed, what is coefficient of fluctuation of energy, and how to store energy in flywheel. Clear? So in this lecture we have to cover more two topics, that is determination of fluctuation of energy, and second topic is dimension of flywheel ring. Clear? So in this lecture we have to cover major these two topics: how to determine fluctuation of energy and what is the design of flywheel. Clear? Okay. So determination of fluctuation of energy. So fluctuation of energy, it is the difference between maximum energy and minimum energy. So in this diagram you see that is a turning moment diagram for the multi-cylinder engine. Here this diagram is turning moment versus crank angle, and in this diagram some positive loop and some negative loop. Clear? So positive loop indicate flywheel gain some energy, and negative loop indicate we have to deliver some energy, or flywheel have to deliver some energy. Clear? So first positive loop, area of this loop is small a1. For the area of first negative loop is a2, and say this is a continue as a a3, a4, a5 and a6. Clear? Positive loop indicate flywheel gain some energy, and negative loop indicate flywheel deliver some energy. Clear? Okay. Now we have to assume energy at point A, that is capital E. Clear? We have to consider energy at point A, that is capital E. Now what is energy at point B? Now for the from between A to B one positive loop is there, and area of that positive loop is small a1. So flywheel gains some energy because positive loop. So energy at point B, that is E plus a1. Clear? Now what is the energy at point B? So clear, that is E plus a1. Now what is energy at point C? Now between B and C one negative loop is there, and area of that negative loop is a2. Clear? So for the negative loop we have to deliver some energy. So energy at point C, that is E plus a1 minus a2. Clear? What is energy at point D? That is E plus a1 minus a2 plus a3. Clear? And energy at point E is E plus a1 minus a2 plus a3 minus f4. Clear? Same, what is energy at point F? That is E plus a1 minus a2 plus a3 minus a4 plus a5. And energy at point G, that is E plus a1 minus a2 plus a3 minus a4 plus a5 minus a6. Clear? So we have to calculate energy at each point. Now we have to identify at which point energy is maximum and at which point energy is minimum. If we take difference between maximum energy and minimum energy, then we can calculate the difference of energy, that is maximum fluctuation of energy. Clear? So this is the determination of maximum fluctuation of energy. Now we have to design the flywheel. Clear? So dimension of flywheel ring. So here is one flywheel is there and one line diagram of flywheel is there. For the analysis purpose we have to take some portion of that flywheel ring. Clear? And that portion make angle at center, that is delta theta. Clear? So we have to design the flywheel ring. Clear? So first of all we have to understand some basic terminology of flywheel ring, that is capital D. Now what is capital D? That is mean diameter of flywheel ring. What is capital R? That is mean radius. Clear? What is capital A? That is cross sectional area of rim. If we cut rim, then the one rectangle is there, so this is the cross sectional area of rim. Now what is rho? That is the density of rim material. Clear? Capital N, that is speed of flywheel, and second one is omega, that is angular velocity of flywheel. Next one is small v, that is linear velocity of mean radius, and what is sigma? That is tensile stress or hook stress. Clear? So this is the basic terminology of flywheel ring. Now this is the front view and side view of flywheel ring. Clear? So you can visualize the motion of flywheel in front view. Clear? So this is the terms with rotational. Clear? That's why flywheel store energy in the form of rotational kinetic energy. Clear? Flywheel mounted in engine at the end of the crankshaft. Clear? Okay. Now we have to consider one small portion. Consider a small element of rim as shown in figure that is subtend at angle delta theta at center. Clear? Now what is the volume of that small element? Now cross sectional area is capital A. So we have to multiply this cross sectional area with its arc. Now what is the equation of arc? You all know equation of arc is angle into radius. Clear? So we have angle is delta theta and radius is capital R. So the volume of this small element, that is cross sectional area capital A into arc. Equation of arc is R into delta theta, radius into angle. So volume of small element is A into R into delta theta. Clear? Therefore mass of this small element. Now in this mass of the flywheel ring is capital M, but we consider small portion. That's why we consider mass of small element is dm. Clear? Now you all know what is the relationship between density, mass and volume. So density is equal to mass upon volume. So mass is equal to density into volume. So dm is equal to density into volume. Density is rho into volume is ar delta theta. So this is the equation for the mass of this small element. Clear? So and centrifugal force on the element acting radially outward direction. So you see in this figure that is df indicates centrifugal force. Now equation of centrifugal force is m omega square r. But in this case the mass of the element is dm. So equation of the centrifugal force is dm omega square r. And also we have the value of dm. So we have to put this value over here. Then equation converted in the form of rho a omega square r square delta theta. Clear? So this is the equation for the centrifugal force. Now what is the vertical component of centrifugal force? That is df sin theta. Clear? And horizontal component of centrifugal force, that is df cos theta. So in this case we have to consider vertical component of centrifugal force. So vertical component of centrifugal force is df sin theta, and we have to put the value of df over here. So equation converted in the form of rho a omega square r square delta theta sin theta. Clear? So this is the equation for the centrifugal force for the vertical component. Clear? Okay. Now vertical upward force is P. Now what is the vertical component of centrifugal force is df sin theta, but if we have to find total vertical force acting upward, so we have to integrate this equation with 0 to pi. Clear? So total vertical force is equal to rho a omega square r square integrate 0 to pi sin theta d theta. Now what is the integration of sin theta? That is minus cos theta. Clear? So rho a omega square r square. Now instead of sin theta we integrate sin theta, that is minus cos theta, and put the limit 0 to pi. Now you all know what is the value of cos pi and what is the value of cos 0. Value of cos pi is minus 1 and value of cos 0 is 1. So we have to put the upper limit and lower limit, and the equation converted in the form of 2 rho a omega square r square. So this is the total upward force. Now you see in this figure total downward force acting is 2 times P. Clear? So this vertical force will produce tensile stress or hook stress, and it is resisted by 2 times P, such that downward direction force is 2P. Now you all know what is the equation of stress, that is force upon area. So what is the equation of force? That is stress into area. So instead of P we can write sigma into A. Sigma is equal to stress, A is equal to cross sectional area. Now we have to equate equation 1 and equation 2. Clear? So equation 1 is 2 times rho a omega square r square is equal to 2 times sigma A, and the 2 cancel out from the both side, and cross sectional area also cancel out from the both side. So equation of the sigma is rho omega square r square. Clear? Now you all know what is the equation for the linear kinetic energy. So V is equal to omega by r. So V is equal to omega. So instead of V, you can write, you replace the value of omega into r with linear velocity. Clear? So omega square r square. So instead of omega square r square, you can write V square. Clear? So is equal to sigma is equal to rho V square. Now based on this equation you can write velocity is equal to under root sigma upon rho, where sigma indicate tensile stress and rho indicate density of the material. Clear? Okay. Now we know that the mass of ring. Now what is the mass of ring? It is the multiplication of volume and density. Now what is the equation of volume? Now you all know, if we multiply cross sectional of flywheel rim to its perimeter, then the equation we get, that is volume. So cross sectional area is capital A and perimeter of flywheel, that is pi into d. So pi d into A, that is the volume of flywheel rim, and what is density, that is rho. So mass is equal to pi into d into capital A into rho. This is the equation of the mass. Clear? Now based on this equation you can write cross sectional area capital A is equal to mass upon pi d rho. Clear? Now from equation 3 and 4 we can find out the value of mean radius and cross sectional area of the rim. Now you also know that is cross sectional area of flywheel rim, that is in the form of rectangle. So the cross sectional area equation capital A is equal to thickness into its width. So based on cross sectional area you also find out the width and thickness of flywheel rim. Clear? So in today's session we discuss about how to determine fluctuation of energy. Clear? And also we design the flywheel rim. In flywheel rim we can calculate the diameter of rim, we can calculate the thickness of the flywheel rim, we can calculate width of the flywheel rim, also we can calculate the cross sectional area of the flywheel rim. Clear? Also we calculate the mass of the flywheel rim. Clear? So this is the design of the flywheel rim. Clear? So in today's session we discuss main two topics, that is fluctuation of energy and how to determine the maximum fluctuation of energy, and we also discuss about design of flywheel. Clear? So next topic we will learn in our next lecture.